Alright, this is a video recording for the Unit 4, Lesson 1, which is on rate of change and slope. So this unit is all about lines and graphing, and one of the most important details about a line is its slope, and that's what we're going to focus on in this lesson. So, couple of definitions that are really important, and they're actually both the same thing. They're two different ways of saying the same idea. Rate of change is the same thing as slope. It's just slope in the real world. It's how one quantity changes in relation to another. It's how the outputs are changing over how the inputs are changing, which is the exact same thing as what slope is. Slope, we just don't normally have context. It's just numbers. We don't have like a real world problem attached to it. One of the key ideas of a slope is it's how steep a line is, and it doesn't change throughout the line. So if you take any 2 points on a line and you calculate their slope, it actually always matches. You might not think it does because one time you might calculate it and it's something like 6/12, and the other time you calculate it and it's 1/2, and you're like, oh, those don't match. But if you reduce this first fraction, you end up realizing that they do match. So that's a big idea here, is the slope is consistent throughout a line. Okay? So with that said, the process for finding the slope or the rate of change is pretty simple and pretty consistent. We're always going to use what's called the slope formula, which I have written up here, but I'm going to put it right here too, just to keep reiterating it. It's y2 minus y1 over x2 minus x1. That means the second y minus the first y over the second x minus the first x. So let's go into this number 1 here. We're going to find the slope between -2, 4 and 3, 7. I'm going to call this x1, y1 because it's my first point, so that's my first x and my first y. And I'm going to call this one x2, y2, my second x and my second y. Well, the slope formula says y2 minus y1 over x2 minus x1. Well, our second y is 7. Our first y is 4. Our second x here is 3 minus our first x is -2. Well, when you do 3 minus -2, it actually becomes 3 plus 2. So we've got 7 minus 4 over 3 plus 2, which is going to be 3 over 5. And that's our slope. We want to leave that as a fraction. When you're asked to find a slope, you want to leave it as a simplified fraction. Later on in the lesson, when we're dealing with rate of change, we can switch to a decimal. But when we're doing slope, we want to leave it as a reduced fraction. Number 2, we're going to do the same thing as number 1. We're going to label our points, x1, y1, x2, y2, and we're going to use that same formula. M equals y2 minus y1 over x2 minus x1. And we're going to plug in that y2, which is -6, minus that y1, which is -2. So it's minus a negative. And then that x2, which is 12, minus that x1, which is 8. And we're getting -6 plus 2 over 12 minus 8. That's -4 over +4, which reduces to a -1. I know I said leave it as a fraction, but if it turns into a whole number, you change it to a whole number. Whole numbers are like fractions. It's unnecessary to put the 1 underneath. Now, number 3 looks different than 1 and 2. In 1 and 2, we were given 2 points. In number 3, we just kind of have to figure out 2 points by looking closely on our grid and finding some points. So this point right here, I picked that because it's a nice, what I like to call a grid point. It's a point on the graph that goes directly through one of these little crosshairs, if you want to call it that, one of these little corners. Okay, we look for something that does that. So I found one, and I'm looking for one more. And the other one that I see one right here. Okay, and if I label these points, this first point is 0, comma, -3, and the second point is 1, comma, -1. And I can actually treat this the same way I did the last problem. We'll call this x1, y1, and x2, y2. And one thing to know, it doesn't actually matter which one you call 1 and which one you call 2 as long as you're consistent. So don't stress about that. Just pick one to call point 1 and pick one to call point 2. So now we're going to use our formula again, which you're going to want to memorize. And we've got -1 for y2 minus -3 for y1 over x2, which was 1, minus x1, which was 0. That ends up being -1 plus 3 over 1 minus 0, which would be 2 over 1, which I could just call 2. My slope is 2. Okay, and now that we have this visual of this graph, it starts to help you understand what slope means, really. Okay, when you look at how this graph is changing over here, you look and you see that the graph is going up 2 and right 1. It's going up 2 and right 1. Another phrase you may have heard in the past for slope is rise over run. And that's what this is representing. It's representing that the graph is going up 2 and over 1. That's what a slope of 2 over 1 means. And now you'll notice if I kept doing that, up 2 over 1, look, I'm going to hit the graph again. Up 2 over 1, look, I'm going to hit the graph again. Up 2 over 1, and it's just going to keep happening throughout. That's the idea of slope. So now we move on to number 4. Find the slope between 5, 8, which we'll call point 1, so x1, y1, and then x2, y2. And we're going to have our slope formula, y2 minus y1 over x2 minus x1, which is 8 minus 8 over x2 is 1 minus 5, which was x1, gives us 0 over -4, which just equals 0. So this is a special case, the slope. The slope is 0. To get an idea of what that looks like, I'm just going to roughly sketch it on a graph. If I look at the point 1, 8, which would be right here, and if I were to look at the point 5, 8, which would be right here, we notice that we have a horizontal line going through those 2 points. That's what zero slope means. Zero slope means the graph is neither rising or running. It's just, or I guess it's just running. It's not rising at all. It's not going up or down. It's just going side to side. In number 5, we're going to notice something really similar. Okay, here's my x1, y1. Here's my x2, y2. And I'm going to use my slope formula, m equals y2, which is going to be 1 in a second. I'm just going to write the formula out. So y2 is 1 minus y1 is 4 over x2 is 2 minus x1 is 2. And I get -3 over 0. And when you try entering that in your calculator, you end up getting an error. What that means is this is actually something we call undefined. It's impossible to divide by 0. You're not allowed to do that. So the slope is undefined, meaning we can't get a numerical result for it. Now, what would this look like on a graph? You might think that the graph doesn't exist because it's undefined, but that's not actually true. We're going to take a look at the graph here. We're going to plot that 0.24, put that up here, and 2, 1, we'll put that down here. And when we connect those points with a line, because that's what we're talking about here is lines, when you connect those points with a line, you see that that's a straight up and down vertical line. That's what undefined slope means. It means you're going to have a vertical line. A really helpful way to remember undefined and zero is with this guy right here. I like to call him slope man. Okay? What slope man tells you is that when you have a positive slope, you're going to see an increasing line. You're going to see a line that goes up from left to right. When you have a negative slope, what you're going to see on the graph is a decreasing line, a line that falls. When you see a vertical line, it means there's an undefined slope. That's the little nose of the face. And then finally, when you see a horizontal line, it means that the slope is 0. So this face is really helpful in determining what kind of line you're dealing with in a particular problem. I would recommend drawing that face on the top of any quiz or test that you take. So with that said, we're going to take a look at number 6. Okay, and number 6 gives us some different lines, and all they're asking us to do is tell whether the lines are positive, negative, 0, or undefined. If I take a look at this first line here, and I match it to the graph, or the slope man, I see that this is a negative falling line, so I would say this is a negative slope. The second graph matches this positive line, so I would say this is a positive slope. This third graph is going up and down, so I would call that an undefined slope. And then finally, this fourth one is going horizontally, and we would call that a 0 slope. So finally, to tie all this together, we're going to look at a couple of real-world problems that use the idea of slope. And when we're using the idea of slope in the real world, we don't call it slope, we call it rate of change. They mean the same thing. Okay, so before heading off to college, Susie was able to save money from her part-time job. Now that she's in college, she has more expenses and must use that money in her savings. The table shows the relationship between the amount of money in Susie's bank account and the number of weeks since she started college. Okay, so what they want us to do is figure out the slope. Well, it looks like we've got, a bunch of ordered pairs here. We've got how many weeks it's been and how much money she has. How many weeks it's been and how much money she has. How many weeks it's been and how much money she has. Well, we can call this x1, y1. It's the first ordered pair. We could call this x2, y2. We could even call this x3, y3, but we don't even need a third point. We remember for slope or rate of change, all you need is 2 points. So our slope or rate of change formula is y2 minus y1 over x2 minus x1. So I'm just going to take 2 of those points and use the formula. I'm going to take the second y, which was 3,100, and subtract the first y, which would be 4,000, and put that over the second x, which was 10, minus the first x, which was 4. That ends up being negative 9,000 over 6, which if you were to divide top and bottom both, I think we could try to divide them both by 6, but I'm not sure that's going to work. We'll see. So I'm going to do 9,000 divided by 6, and that gives me 1,500, so that actually works. My slope can reduce to 1,500 over 1, or just 1,500. Now, this term here, unit rate. What that means, and I've put the definition down here, it's the amount of change in y per 1 unit of change in x. So let's put that into words that make sense for this problem. Over 1 week, 1 unit of change for x, over 1 week, how much is the money changing? Okay, well this guy right here, $1,500, or 1,500 over 1, this guy right here, well, I don't want to highlight it because it's not our final answer, but 1,500 over 1, that's actually a unit rate right there, because it's 1,500 whatever y is over 1 whatever x is. Well, y is money, so this is $1,500 over 1 week. And that's a unit rate, $1,500 per week. That's how much money she's spending. Now, I left out, so fix that. I left out a negative sign on that. So she's spending $1,500 a week. She's not making it, she's losing it. That's why it's negative. And that's the end of that particular problem. Now the last problem is going to tell us why it's so important to be able to find a unit rate. Because what we're going to do is we are going to, if we read this, it says the table shows draining a pool at Carroll Stream and draining a pool in Glen Ellen. They ask us which pool is draining at a faster rate. Well, the way that you can tell that is by doing unit rates. If you find it each for 1 unit of change, you're going to be able to compare them. Okay? If one is saying, like, I drain 1,000 gallons for every 3 hours, and the other one says I drain 1,200 for every 5 hours, it's hard to compare what's happening over 3 hours to what's happening over 5 hours. If I can get both to be per 1 hour, it's going to be easier to compare the two rates. So what we're going to do is find some slopes, or rate of changes. Okay, I'm going to call this, for this problem, x1, y1, x2, y2. So my slope formula for Carroll Stream would be y2 minus y1 over x2 minus x1, which is going to be 1,100 minus 1,600 divided by 3 minus 0, which would be negative 500 over 3. Now that's not a unit rate. What I'm going to do is I'm going to divide top and bottom to make the bottom 1. So I'm going to divide top and bottom by 3. The bottom, well, 3 divided by 3 makes 1. That was our whole goal. The 500, we're going to divide by 3, and we're going to get 166.67. I'm sorry, that was negative again. Okay, and that's our unit rate for Carroll Stream. And that is gallons per 1 hour. It's a unit rate because we made this 1. That was our goal. So this right here is our unit rate for Carroll Stream, and I'll put that up here. Carroll Stream, we've got negative 166.67 gallons per 1 hour. For Glen Ellen, we're looking at a graph here. I see a nice point at 0, 1,200. And I see another nice point down here at 2, 900. This is x1, y1, and this is x2, y2. So we're going to make slope again, okay, or rate of change. M equals y2 minus y1 over x2 minus x1. My y2 is 900. My y1 is 1,200. My x2 was 2. My x1 was 0. And we get negative 300 over 2. What that means is they're able to drain 300 pounds or 300 gallons over the length of 2 hours. Over 2 hours, we're draining 300 gallons. Okay? Well, that's not a unit rate. So again, I'm going to divide top and bottom by a number to make it 1 on the bottom. Dividing by 2 does that. So I get negative 150 over 1. And remember, y is talking about gallons. So I'm going to put gallons. And x was talking about hours. So we're draining 150 gallons per 1 hour for Glen Ellen. So I'm going to put that up here. Negative 150 gallons per 1 hour. So now who's draining faster? Well, 150 gallons is not quite as fast in terms of draining as 166.67 gallons. So I would say that Carroll Stream is draining faster. Carroll Stream is draining faster. They get rid of more water in 1 hour than Glen Ellen. Then finally they say write an equation for each pool to show the relationship between the number of hours draining, x, and the water remaining in y gallons, or y in gallons. Okay? And this is just kind of a preview for something that we're going to do more so later. But if we were trying to think about start change like we've done in the past, well, if I'm looking at this guy, our starting amount is 1,600 gallons for Carroll Stream. So for Carroll Stream, we would say that we start with 1,600. And then if you're thinking about change, we've always looked at change as being like per hour, per mile, per something like that. Well, if you look at this, we're getting negative 166.67 per hour. That's your change. So we're plus negative 166.67 per x. And I would just clean that up by saying 160 or 1,600 minus 166.67x. And then for Glen Ellen, we're starting at the beginning of draining at 0 hours. We're starting with 1,200 gallons of water. So our starting amount is 1,200, and our change is slope, or rate of change, negative 150 per hour. So minus 150 per x. And we'll write that out as 1,200 minus 150x. And that is the rest of that problem, and that's the end of these notes.